Hi, this tutorial is the second part really of the tutorial on parameter mapping with FM synthesis. And what it's doing is kind of zooming out a bit from that tutorial and thinking about neural networks and parameter mapping. This process is more broadly called regression, which is taking one set of data and another set of data and trying to figure out the mapping, the relationship between those two sets of data. And what we do is we train a neural network to find the mappings between two sets of data. In the previous tutorial we did that with FM synthesis. We took two mouse coordinates and we fed them into a neural network model, and we associated those mouse coordinates with different parameter settings on a synthesizer that had 7 parameters. And then we trained the model to do those mappings for us. And what it did was quite interesting. It didn't just do the mappings we trained, but it guessed the mappings in between. So it made quite an interesting instrument that's quite musical to explore. And this is part of a kind of broader study of mapping. So we don't just have to use an FM synthesizer. We can use any synthesizer. Anything that takes a signal, we can control it from a neural network. And we don't just have to use mouse coordinates to control the neural network. We can use other things like oscillators or sounds, for example, or some kind of controller. So this tutorial is really focused on this broader problem of parameter space mapping and regression. And the idea is that we have a script here which is really generic. And what you should be able to do is take this script and use it with your own work. So you can set it up to talk to whatever you're doing in the live coding window, and then train a model to do some regression parameter space mapping for you. Let's have a look at this script then. So the last script we looked at in the FM tutorial was really just set up just for that patch. But this one is configurable, so you can use it yourself. What we have is some variables that you can configure here. So this one is the number of inputs. So for example, if we were sending 2 mouse coordinates, we'd set this variable to 2. And this is the number of outputs you want from your model. So if we were controlling a synthesizer with 50 parameters, we'd set this number to 50. Those are the 2 basic settings you need. This setting structure here, I'm just going to kind of skim over it because this tutorial isn't really about the details of neural network architecture. It's more about the creative process of using a neural network. So we don't strictly need to know what this does. But if you do know a bit about neural networks, this is the sizes of the hidden layers. And so if your neural network isn't training very well, you can make these numbers larger as a general rule, but maybe not too large. And or you might want to deliberately make them small to make a network that behaves in some kind of unpredictable ways that won't train very well. This next variable here is a Boolean. We can set it to 1 or 0, and it says whether we use the CPU in our machine learning. Most machines, modern computers, will have a graphics processor that you can use for machine learning. And TensorFlow library, which we're using here, will pick up your GPU automatically and use it. GPUs are really great for doing super fast processing of kind of large sets of data. They work in parallel, so they're much faster than a conventional CPU in your computer. But there is a downside that often the pipelines associated with communicating with a graphics processor are optimized for sending data to the graphics processor, and they might not have such a fast line coming back out of the GPU. So what that means is sometimes they're not so good for real-time machine learning for music, because in music we often need to very regularly pull data out of the machine learning model. And if that machine learning model is on a GPU which is having trouble sending data back fast enough, then it's going to create some delays and some jitters, which we don't really want. So for real-time music, if your model will run on a CPU, it's probably going to be better to use the CPU if you can. Let's see how this script works then. And this will really be a bit of a review of the previous tutorial. I've got a very basic example you can try here. And this is super basic. It's just sending one parameter into this model, and we're going to map that to two parameters in this synth. I'll run the code to see what the basic sound is like. This patch is pretty basic. It's a couple of saw waves, and they're both actually three saw waves, and they're all slightly detuned from each other. So you can get a bit of variation with a couple of parameters from this. Now let's have a look at the machine learning side. Again, this is focused on thinking about the creative process of using parameter mapping and not really getting into the details of what or why about the model. I'm just going to run this bit of code which is going to do all the setup, and then the steps are fairly clearly numbered here. I'm going to do something pretty similar to the last tutorial, which is explore a couple of different random states of the patch in the audio engine, and I'm going to make some associations between the input and the parameters that we're sending to the audio engine, so that when we change the input, it'll explore the parameter space. So this is with a mouse X, so I'll associate one sound with this side of the screen and another sound with this side of the screen. Let's just clear that. So audio engine on again. Now that's the training data collected, training data which associates input with outputs that we want to send with the synth. The next stage is to make a model. This section of code creates the model. The next section, just like in the last tutorial, converts this data into the right format for TensorFlow, and then we can do the training here. I'm going to just switch this down a little bit. And I'm going to run it a few times. Okay, actually that looks really low now. So let's move into prediction mode and see if that mapping worked. So it seems like that was successful. And that wasn't really meant to be a kind of spectacular example. It was more just to show from a very simple point of view how this script works and how you might think about applying this to your own work. So there's a bunch of tasks here, a couple of tasks which you can suggested to try out yourself. So thinking about adding in extra outputs from here and extra inputs from here. So if you can try and do that yourself, you'll get a good feeling for how the script works before you can apply it to your own stuff. So where can we go with this? Parameter mapping has got a lot of creative potential. These are a couple of ideas that you might want to explore. I'll just go through these two examples. The first one here is parameter mapping in sequences. So this was parameter mapping through a kind of constant sounds, but what about rhythmic work? In Sema, everything is a signal. So that means we can use signals to manipulate sequences just as much as we can use them to manipulate sounds. What's going on in this patch? We're sending mouse X and mouse Y 20 times a second over to here. So I'm going to change the number of inputs here to 2. And we're receiving 5 parameters back from the machine learning model. So I'm going to change this to 5 parameters. What happens after this? We got 3 sequences here. We're using the ratio sequencer, and these sequences are plugged into samples, which gets mixed together here, and then they get put through a reverb and sent out. These parameters which are coming in are being used for the ratios in the sequences. So what you'll hear is that when we explore different random settings of this patch, we'll get different rhythms, and some of them will sound good, some of them won't sound good because they'll feel a bit uncomfortable because they're quite badly out of time. And so what we need to do is just kind of go through this parameter space, find some good ones, and I'll choose 2 to train in the top left and bottom right corners of the screen. So here goes. Let's initialize this patch again, and that should have created all the channels that we needed. I'm going to switch on the audio, explore the space a bit, and find 2 different patches, parameter settings to train to. Let's try that first one. I'll put the mouse in the top left. Now another one. That's some training data collected then, with some slightly different rhythms. Let's create a model, a blank model, which we're going to train to associate these areas of the screen with the different parameters for this synth. Convert the data to TensorFlow and run the training. So that's a nice low loss now. Let's see what it sounds like. So you can hear there's a bit of a variation between these 2 rhythms as I move the mouse around. And you could go on and make that a lot more complicated by training maybe 3 or 4 areas of the screen with different rhythms. If you want to explore the patch, you could try maybe changing the samples here, changing the speed of the samples, adding in more parameters which change these numbers here, or changing the reverb.